Hi guys. So essentially we are going to start our lecture over chapter 3, which is biological molecules. We're going to start with talking about carbon atoms and organic molecules and how they're put together. Then we're going to go on to bigger molecules. And we're going to end with the online lecture at carbohydrates. The rest of it we're going to talk about in class and actually have some activities that we're going to do. So why are they important? Well, all organisms are made up of cells, and cells are essentially made up of these particular macromolecules known as carbohydrates, proteins, lipids, and DNA. Now, as we know, DNA is the informational unit that puts us together, so essentially tells our body how to make us. So that should be a big indication of why we're important, why that's important. Now, as you can see here, it also shows you a cup of coffee with some sugar going into it. Well, sugar is a macromolecule. It's essentially known as sucrose, and it's a disaccharide or a carbohydrate. And so essentially we can take in that form of sugar, break it down to its simple, most basic element, and then use it for things like running or just functioning every day. So hopefully that helps make it understandable by why we need these things. Now, you can even see it essentially as simply on nutritional facts on the back of food. And essentially, it talks about calories, and we'll get more into what calorie means when we talk about metabolism later in the semester. But if you look on this, you can see just basic that we have fats, we have carbohydrates, and we have proteins. So essentially, that can give you a good idea about how important they are, that they are in the basic components of food. So let's talk about carbon atoms. So let's talk about carbon. Now, carbon is the fundamental element that we talk about when we talk about organic molecules, right? Now, if you remember from the chemistry section, you had carbon. Change this color. Okay. There. Oops. Sorry about this. For some reason, this is not wanting to work. Let's see if that works. Yes. And so if you remember, the atomic number for that was essentially 6, which meant there were 6 protons, right? Which it's equal, so there are 6 electrons. And so if you remember about the valence, right, on the inside you had 2, so -2 meant there were 4. So we had 4 here, so essentially what we're trying to get is 4 more. And so when we do the Lewis dot structure of this, remember, you put 1 in each corner. And so carbon can essentially interact with 4 other elements, or depending on how many electrons they need, you can interact with the same element a couple times. So you can see right there that it's extremely important. It's the molecule that's extremely abundant in living organisms. Now, organic molecules, it means that there is essentially carbon and hydrogen in it. That's what organic means. So if I have something like CH4, right, that has carbon, hydrogen, it's organic. If I have something like H2O, right, this is going to be inorganic because there are no carbons or hydrogens. You have to have both carbon and hydrogen to be considered organic. So with that in mind, I'm going to leave you with the following molecules here, and I want you to tell me if they are organic or not. Right? Methanol and carbon dioxide. So with that in mind, I'm going to pause here, and I will be back